Thank you for giving me an introduce myself. So, in fluent English. So, unfortunately, my English is not fluent. So, I wrote everything I want to say into the slide, but unfortunately, the screen is not so big, so it is difficult to read small characters. So you can download my slide PDF from this QR code. So if you have a laptop, so you can download here, from here. Oh, so many people take the picture. Is it okay? Yeah. So continue the presentation. So I want to talk about Ractor. So at the previous Ivo's talk, so he introduced many things I want to talk. So I can eliminate many things. But I want to talk about what is the Ractor and why we need to introduce a Ractor, and what's the situation with the current Ractor, and what's new in Ruby 3.4, and in the future. Today I want to, so at first I want to apologize that, so this year I was unwell for a long time, so I didn't achieve much contribution for the lecture. So in this presentation, I show you the many background and philosophy and the current problems. So maybe someone you listen my previous talks, so then you feel that oh, it is same things, but please listen to my talk as a refresher. Anyway, I'm Ruby interpreter developer from 2004, so 20 years. I continue developing the Ruby interpreter and did some achievements. So that was introduced by Matt, today's keynote. And also, so this is advertisement, but I will organize a Ruby Hack Challenge workshop tomorrow. So if you have any feature request, if you have any questions internal of the Ruby interpreter or something you want to hack the Ruby interpreter, please join us. And also, so in the Ruby Hack Challenge session, so at the 12 to we have ask the Ruby committer session, so please come join. Anyway, and another introduction is I'm maybe the shortest description writer in the GitHub sponsor. Anyway, do you need to check this? Anyway, no problem. Anyway, so what and why we need to introduce Ractor? So Ractor was introduced from Ruby 3.0, and it enables the parallel computing on Ruby for more performance on multi-cores. So it can make a faster application. And also, Ractor achieves robust concurrent programs. No bugs because the object sharing is highly limited. So this is some idea about Ractor. But today I want to show more and more background. So the previous Ivo's talk introduced the GVL. So GVL is so on the CRuby, so threads cannot run in parallel because of the GVL, even if the computer CPU has multi-cores. So for example, if we have 3 threads, then we cannot run only one thread in the same time. For example, so at this time, so the thread B, only thread B can run because only one thread can run in the same physical time. With Ractors, so Ractors has each Ractor has GVL. So in this case, so this timing, the thread B and thread D on the different Ractor can run in parallel. So this is Ractor. And this is why we want to introduce Ractor into Ruby. So with the Ractor, so we can run 4 computing intensive tasks with Ractors. So we can run the 3.7 times faster. So very big win. So you can write this kind of recursive program in Ruby. But the bad news is nobody writes that. So by the way, the name of GVL, so this is the same same content about the previous IVO slide. But so the GVL has meant global or giant virtual machine locks per virtual machine. So virtual machine is similar to the process, the Unix process. So and so in Python they say the GL, and it is more familiar. We use this term virtual machine because we tried to introduce multiple virtual machines in one process, and we choose the virtual machine on this context. But this trial was we wrote some academic paper about the multiple virtual machines, but this trial was failed. So if you have interest why this trial was failed, then please ask me later. Anyway, so with Ractors, so GVL is not a global. This is kind of giant, but not so giant. So maybe middle big problem, locking. So each Ractor has GVL, and the Ruby virtual machine has many GVL nowadays. So great or good variable lock or anything. So if you have any good words, so please tell me. Anyway. Good song. Anyway, so back to the Ractor philosophy. So we think that the parallel programming is very, very difficult because we need to synchronize the shared mutable data or objects between threads. So we cannot, if we manipulate any objects without synchronization, the program will be crashed or something critical issues. On the threads system, it is very easy to share an object, and it is hard to trace. Furthermore, if we use many libraries, so we couldn't read any which library mutates the data or something like that. So it is same on current Ruby's concurrent threads. So previous IVO's presentation says that the GVL doesn't protect your application. but the context switch point is very limited, so it is easier than the the parallel computing. So so degree of, if we show the degree of the difficulty of programming, so the parallel programming is most difficult, and the serial program is very most easy. So it is more easier than parallel programming. The current CLB thread is with GVL is easier than parallel programming, I think. So this figure, this page is quoted from their famous "Why Threads Are Bad Idea" presentation by a famous professor. So he says that the thread programming only by wizards. So 30 years. So this presentation is 30 years from 30 years ago. So the example is Visual Basic program. So maybe I think the Ruby is easier than Visual Basic. So maybe Ruby is here, same as on the Visual Basic, I think. Anyway, so I think that the thread programming is should not be allowed anymore, I think, for the so easy programming. And also I have another reason why we introduce GVL. So we want to keep the quality of the interpreter. So the Shilby doesn't allow to stop by the critical error. So segmentation fault, for example. So if you see the segmentation fault, it should be interpreter's bug, not of your application's bug. So to keep this condition, so accessing all of mutable objects should be thread safe. For example, the array, hash, or string. So basic data structure written in C should be protected by some kind of fine-grained mutex or something like that. So thanks to the GVL, we don't need to care because the GVL protects all of them. So Ruby is open source software and the developer is limited. So the productivity of the Ruby interpreter is very important for us. So recently, the Shopify provide many developers. So the situation is some maybe changed, but maybe this productivity is important. This kind of the importance is not changed, I think. And also, another concern is the performance. So introducing such a thread safety locking or synchronization needs many overhead. So I think the current so GVL is most fastest way, I think. So by the way, the recently Python community decided to tackle to release the GIL, Global Interpreter Lock. So such a difficult issues. So I respect this decision, and I'm looking forward to see the conclusion on this trial. So back to the background of the parallel programming. Why the parallel programming is difficult? So difficulty is come from the shared mutable objects. So so if we don't have a shared mutable object between threads, so we are happy to make parallel programs. So how to solve this issue? So there are many ideas. So for example, so prohibits the mutable data, mutable objects. Okay, let's use the Alan or Ractor or other functional program languages. Okay, trace by typing. So type system can help to avoid such a data, such a thread safety issues. So you can use Rust. Another idea is manage or so all of mutation can be protected with transaction memory. Then you can use a closure language. So trace mutation ends looking by tooling, so some debugger or something like that. So you can use a cron, so thread sanitizer or something similar tools. Or so prohibits sharing data. So you can use forking the process or microservices, DRuby, or failed MVM projects. So there are many ideas, but it is difficult to introduce them into Ruby. For example, so so at the keynote, if must say, oh, let's prohibit the mutation. For example, if we cannot assign any instance variables. Maybe Mats has many so claims, I think. So our choice is the separate shareable and unshareable object carefully. So this is a Ractor. So we introduce the Ractor as an isolated object space. So objects cannot access to the other Ractors basically, and so it means that most objects are unshareable. And we introduce some shareable objects, such as immutable objects, or classes and modules, or special other cared objects. So in this trick, we can only focus on the shareable objects, to protect carefully. But so if we separate the object space, but sometimes we want to share the state. For example, so this is the simplest example. So they want so if we want to count some tasks, how many tasks are done, then so with the thread, it is easy to share this count local variable with this kind of data, this kind of program. Please note that this count doesn't have enough locking system, so this program is not a complete one. So this is why it is the thread programming is difficult. Anyway, so on the Ractor system, so we have maybe 3 options. So the simplest way, so easiest way is to use the external database. For example, the relational database, Redis, or file system, or something like that. So another one is using the actor or transaction variable. So I want to introduce 2 and 3. So we can enclose the state to the one Ractor, and worker ask to increment them, and the main Ractor ask to get the counter value, and the value will be returned to the main Ractor with this kind of Ractor programs. So this is a very simple way to make actor style programs. So another one is using the transactional variable. So transactional the word transactional is come from database and research from software transaction memory. So there I eliminates the details whether we can use this transactional variable like with this gem like that. So with the transaction memory or variable, we can share with the share the state with Ractors, multiple Ractors with a safety way. So this is current so the ideas of Ractor. So I want to show the current situation. So good news is that of course the Ractor was released with Ruby 3.0, so maybe about 4 years ago, and Ractor support. So debug gem I wrote is aimed to support Ractor and the MN threads for lightweight Ractor and thread creation. Technique was introduced last year, and the few usage reports which achieves the performance improvements and more. The bad news is the Ractor, so debug gem doesn't support the Ractor yet, and MN thread wasn't tuned for the Ractor more, and only few usage reports are there. So maybe because so there are many reasons, but the most biggest issue is ecosystem is not grown with Ractor. So for example, so to achieve the isolated object space, we introduce many limitations to the Ruby language. So we need to rewrite existing libraries. And for example, the Rails doesn't work with Ractors. So maybe we need a huge effort to run Rails on Ractors in parallel, I think. And for example, the simplest example we cannot run on Ractor is here. So it doesn't work on the Ruby 3.3 because the first PP call requires the PP library. And after that, the require is not allowed on the non-main Ractors. So this is problem. And another problem is the performance. So I don't show the details, but this disabled GC disabled situation, we can check, we can get good performance. However, if we enable the garbage collection, so the performance is very slower with garbage collection. So this is so not tuned. So Ractor is not tuned for the garbage collection. So this is a big problem to introduce the Ractor to the your production. So we have many issues, and we need to improve step by step. So the Ruby 3.4. I want to introduce some features. By the way, so this is off topic. So Ruby 3.4 introduces unused block warning. So maybe somebody writes this kind of program like that. So the method foo with block, but if we want to show the result of this method, then this block is passed to the method p accidentally. So we introduce a new warning. So for example, this method foo doesn't accept any block, and passing the block, then uh, warning this one with high dash W option. Anyway, so back to the Ractor talk. So PP is a good example. We need to introduce support the Ractor require on another Ractors. So and also the outroad is also the good example. So we achieve the requires on Ractors on Ruby 3.3 3.4 with the ask main Ractor to require and wait the result like that. So if the child Ractor run require, then ask to the main Ractor to make a new thread to require. And the require on this thread in main Ractor, and the back to the original so child Ractor returns the result, requires result, and restarts the program here. And this Ractor require method is called with this anonymous prepended module. So you don't need to care about this one. So you only need to require as usual, and the underscore require method will be invoked. After that, so another topic is this is not implemented yet, but maybe timeout library will support Ractor. So the net HTTP library can work fine on Ractors. There are another new features on Ruby 3.4. For example, the thread supports, and so in future, so there are many things we want to improve. Whether the lecture aware GC tuning is maybe most most important thing, I think. So the so previous on previous talk, the Ivo proposed that the parallel garbage collection or something like that. So if we introduce the Ractor local garbage collection, so each Ractor can the garbage collection in each Ractor. So it means that the parallel garbage collection. So I want to try. So we tried this implementation in 4 years, but it is not implemented yet. So next year, I want to achieve that. So anyway, so I introduced many philosophy and the background of the lecture, and show the kind of situation and what's new on 3.4 and more future. So thank you so much.